Hi, this video will explain what bipolar junction transistors are and how to use them. Bipolar junction transistors, or BJTs, have many functions, but this video will focus on two prominent ones, that being as an amplifier or as an electronic switch. In this circuit, I have a 10 volt DC supply connected to a transistor over here. This particular transistor is what is known as an NPN transistor. As you can see, even though the circuit appears to make a complete track all the way around here, current is not currently flowing. That's because in an NPN transistor, in order to allow current to flow through, you need to supply a current to this leg here, which is known as the base leg. Now, if I connect the switch to the positive side of the battery, current begins to flow through the transistor successfully. Then, if I flick the switch back off, current ceases. The ability to use an electrical signal to switch instead of using the switch itself is fundamental to modern electronics. Many modern computers have billions of transistors in them. Let's take a closer look at what's going on inside the transistor. An NPN transistor has three terminals: the collector, which is C in this diagram, the base, which is B in this diagram, and the emitter, which is E in this diagram. For an NPN transistor, current flowing out of the emitter is equal to the combined current flowing into the base and the collector. Or in other words, IE equals IB plus IC. Now let's go back to our circuit. If I now flick the switch back to the positive supply, current flows again. The current moving into the collector is 100 milliamps up here. The current moving into the base is 1 milliamp. And the current leaving the transistor through the emitter is 101 milliamps. This proves our IE equals IB plus IC, so 100 plus 1 equals 101. Now, you may be wondering, how are these values chosen? Well, the current flowing into the base itself here is controlled by this resistor. If I change this resistance value, the current here will change, and subsequently so will the others. Then, that current coming into the base pin is multiplied by this transistor's gain, or forward beta, which is 100, so 1 milliamp multiplied by 100 gives 100 milliamps. Then the 1 milliamp on the base combines with the 100 milliamps coming in to the collector to give us a 101 milliamp output on the emitter. This is how a transistor is used as a current amplifier. For example, you could input a small current from a chip, say, and output a large current to drive some high power components, such as a motor or something similar. So far, we've seen how to use the NPN transistor as a switch or as an amplifier. Now we're going to try and do the same thing, but with a PNP transistor, the other standard type of transistor. Looking at the diagrams on screen, we can compare the NPN transistor and the PNP transistor. The main fundamental difference between the two is that NPN transistors require a positive current on their base pin. In other words, they source current, whereas a PNP transistor requires a grounded connection to let current flow out, or in other words, they sink current. Subsequently, the current out of the collector pin down here is equal to the input current on the emitter minus the control current on the base pin. Or in other words, IC equals IE minus IB. This circuit is much the same as our previous one, only it uses a PNP transistor instead of an NPN one. Now, if I connect the switch to the positive side of the battery, as it currently is, you can see no current flows, so the inverse of the NPN. However, if I connect the switch to the grounded side of the battery, you can see that current begins to flow. This shows us how to use a PNP transistor as a switch, being that it is essentially an inverted NPN transistor. This circuit also shows us how to use a PNP transistor as a current amplifier. We can see the current flowing out of the base pin here is 1 milliamp, which when multiplied by the transistor's gain of 100 gives current flowing out of the collector at 100 milliamps, meaning that the emitter needs to draw enough current to feed both the base and the emitter, which is them added together being 101 milliamps. In this way, we're using a PNP transistor as a current amplifier in a similar fashion to the NPN transistor. Overall, transistors are truly one of the greatest inventions of the modern age, allowing us to control complex tasks with ease. Thanks for watching. Be sure to like the video if you liked it, subscribe if you loved it, and have a good day. See ya!